This is Pre-Calculus Section 6.4 Notes Part 2. So we were trying to decide if there was a second triangle for example 2. We're looking at the first angle we found, which was angle B. We took that 34.4 and we said if this is in quadrant 1, angle B would be 34.4, which we already found, right? But what if this was an angle in quadrant 2? Okay, because we know that sine is positive in quadrant 2 as well. So we subtracted 34.4 from 180 and said the other possibility is that angle B could be 145.6 degrees. So then the question is, can that work, right? Can angle B, whoops, sorry about that. Oh boy, there we go. Can angle B equal 145.6 degrees? Well, we have to work with what we know, okay? We know that we were given, in this problem, angle A, and given information doesn't change. So if angle A was 135 in the first triangle, it has to be 135 if there's a second triangle as well, okay? So we know that. And if we add this new possible angle B, which was 145.6, okay, then that is going to total like about 280.6 degrees. Is it possible for us to have two angles that total over 280 degrees and still have room left for a third angle, angle C? No, it's not possible. Okay, this is already greater than 180 degrees, which we know is what our triangle angles have to total. So the answer is, this means that there is not a second triangle for example 2. However, in the next example, we are going to look at what does it look like when you have a triangle that either has no solution or has a second triangle. So you'll get to see both examples, okay? All right, so taking a look at the next example, which is example 3, we're going to solve this triangle using the law of sines. Let's label on the triangle the information that we're given. We know side A across from angle A is 50. We know side B across from angle B is 100. And we know the measure of angle A is 50 degrees. So right away, this information satisfies the side-side angle scenario, which we know is the ambiguous case. Okay, we're going to start with our given information. We know we've got angle A and side A, and we know we've got side B. So the first thing we can do is we can look at sine of A over A is equal to sine of B over B. We can plug in what we know. We know A is 50 degrees, so sine of 50 degrees over 50 would be equal to sine of angle B over 100. Okay. Then we do our fancy algebra. And solving for sine B, we're just going to multiply both sides by 100. So sine of B is going to be equal to 100 times sine of 50 degrees divided by 50. We grab our calculator and we find that the sine of angle B is 1.53. Okay, now, right now, a warning bell should be going off in your head. Because if you think about what you know about the unit circle, sine and cosine each individually always have to be less than 1. Because sine squared plus cosine squared has to equal 1, right? So it's not possible for the sine of angle B to be greater than 1. And if you were to grab your calculator and do the inverse sine of 1.53, you would find that your calculator will give you an error. Okay, so this is not possible. Okay, the sine of an angle is always less than or equal to 1. All right, so this one is the no solution situation. Our last example, we are going to take a look at the ambiguous case, and we are going to have a second triangle. So we'll take a look at what this looks like. All right, we're going to start by labeling our triangle. Side A is 30 across from angle A. Side C is 42 across from angle C. And the measure of angle A is 37 degrees. All right, so we know that this information satisfies our side-side angle scenario once again. We are going to start with sine of angle A over side A. I'm just going to go ahead. Now we've done this a few times, so I'm just going to go ahead and plug those numbers right in. So we're going to have the sine of 37 degrees over 30. And since we know side C, we have to do angle C over side C. So it'll be sine of angle C over 42. To solve for sine C, we are going to multiply both sides by 42. So sine C will be equal to 42 times the sine of 37 degrees divided by 30. We grab our calculator. We find that the sine of angle C is equal to 0.8425. So to find the measure of angle C, we have to do the inverse sine. So angle C is going to be equal to the inverse sine of 0.8425, which tells us, once we grab our calculators and type that in, make sure you're in degree mode, that angle C is 57.4 degrees. Okay, so now that we know that, 57.4, we can go ahead and fill that in. And now that we have that information, we can just subtract from 180 to get our remaining angle B. So the measure of angle B is going to be equal to 180 degrees minus 37 degrees minus 57.4 degrees. Grab your calculator. Angle B is going to be equal to 85.6 degrees. Okay, and we have one more thing that we need to find, and that is side B. So we're going to use the law of sines one more time. And we're going to say that we're going to use angle A and side A again. I always like to go back to using the given. So the sine of 37 degrees over 30 is going to be equal to, but this time if we want to solve for side C, we're going, or excuse me, we want to solve for side B. So we're going to use angle B. So it's going to be the sine of 85.6 degrees over B. And algebraically, B is going to be equal to 30 times the sine of 85.6 degrees divided by the sine of 37 degrees. Okay, you grab your calculator, you type that in, and you find that side B is 49.7. All right, so we have solved this triangle. All right, the first triangle, I'm just going to go ahead and I'm going to write all the information here on the left-hand side. Okay, we've got angle, or side A was 30, measure of angle A was 37 degrees, side B was 49.7, measure of angle B was 85.6 degrees, side C 42, and measure of angle C was 57.4 degrees. Okay, so we know that that is a triangle. The question is there a second triangle? We are going to do exactly what we did in the previous problem. We're going to go back to the first angle found. The first angle that we found in our problem here, the first angle that we found was angle C, okay? And we found angle C to be 57.4 degrees, okay? The other possible measure for angle C is going to be 180 minus 57.4. Because again, remember, it's that, is it in the first quadrant or is it in the second quadrant thing? Because sine is positive in both quadrants. So that means that the alternate angle C, I like to call it C prime, could be 122.6 degrees. So then the question is, does that work? Well, we have to go with what we were given, okay? Angle A was given as 37 degrees. So if we add to it this new angle C, so I'm going to call it C prime, at 122.6 degrees, that gives us a total of 159.6 degrees. Is there enough room left for an alternate angle B? And the question is, yes, there is some room left. We'll call it angle B prime, okay? So then angle B prime would be equal to 180 degrees minus 159.6 degrees, which would be equal to 20.4 degrees. So I'm going to pause right now and I'm going to fill in my information. The information that was given for triangle 1 remains the same for triangle 2. So side A is 30, angle A is 37 degrees, and side C was 42. That was given. Now we just found that our new, we're going to call it angle C prime and angle B prime. Our other angle C was 122.6 degrees. And then when we subtracted from 180, we found that the new angle B for our second triangle would be 20.4 degrees. So now all that's left is for us to find side B for this second possible triangle. So we're just going to use the law of sines to find side B. Again, go back to the given. I'm going to go with sine of angle A, which was 37 degrees, over side A, which is 30. And that has to be equal to, now if we're trying to find our new angle B, then it's going to be the sine of 20.4 degrees over side B. Do the algebra to solve for B. We get that B would be equal to 30 times the sine of 20.4 degrees divided by the sine of 37 degrees. Grab your calculator, make sure you're in degree mode, and you should get that side B is equal to 17.4. And so we have just found the information for the second possible triangle.